A nebula is named from the Greek word for cloud. Nebulae come in many shapes and sizes and have a way of captivating those that observe and photograph these deep sky objects in space. Nebulae have been divided into 5 major categories. These are emission nebulae, reflection nebulae, dark nebulae, planetary nebulae, and supernova remnants. Emission and reflection nebulae tend to be fuzzy in appearance and lack any noticeable shape or structure. They are also known as diffuse nebulae. Emission nebulae are clouds of ionized gas that, as the name suggests, emit their own light at optical wavelengths. Their mass generally ranges from 100 to 10,000 solar masses, and this material can be spread over a volume of less than light-year to several hundred light-years. One of the most famous emission nebulae is the Orion Nebula, M42, located just below Orion's belt. A reflection nebula is created when light from a star is scattered or reflected off a neighboring dust cloud. The scattered light is slightly polarized and has a spectrum similar to that of the illuminating star, only bluer. This shift in color arises because the typical size of dust grains in the cloud are comparable to the wavelength of blue light. The result is that blue light is scattered more efficiently than longer, red wavelengths, giving the characteristic blue color for these nebulae. The nebulosity surrounding the stars in the Pleiades is perhaps the most well-known example of a reflection nebula. Dark nebulae are interstellar clouds that contain a very high concentration of dust. This allows them to scatter and absorb all incident optical light, making them completely opaque at visible wavelengths. They are most obvious when located in front of a bright emission nebula, example the Horsehead Nebula in Orion, or in a region that is very rich in stars, example Barnard 68 in Ophiuchus. The most famous example in the southern hemisphere is the Coal-Sack Nebula near Alpha Crux in the Southern Cross. The average temperature inside a dark nebula ranges from about 10 to 100 Kelvin, allowing hydrogen molecules to form and star formation to take place. Large dark nebulae that can contain over 1 million solar masses of material and extend over 200 parsecs are known as giant molecular clouds. The smallest ones, called Bok globules, tend to be less than 3 light-years across and contain less than 2,000 solar masses of material. Planetary nebulae represent the last stages of evolution for low and intermediate mass stars whose main sequence mass was less than about 8 solar masses. After evolving through the asymptotic giant branch on the Hertzsprung-Russell diagram, a phase characterized by shell burning resulting in radial pulsations that drive prodigious mass loss, these stars possess thick, dusty, molecular circumstellar envelopes. The first planetary nebulae discovered was Messier 27, the dumbbell, catalogued by Charles Messier in 1784. The Helix Nebula, NGC 7293, is one of the most well-known planetary nebulae. A supernova remnant, SNR, is the remains of a supernova explosion. SNRs are extremely important for understanding our galaxy. They heat up the interstellar medium, distribute heavy elements throughout the galaxy, and accelerate cosmic rays. How do we classify supernova remnants? Shell-type remnants, crab-like remnants, and composite remnants. Shell-type remnants. The Cygnus Loop is an example of a shell-type remnant. As the shockwave from the supernova explosion plows through space, it heats and stirs up any interstellar material it encounters, which produces a big shell of hot material in space. We see a ring-like structure in this type of SNR because when we look at the shell, there is more hot gas in our line of sight at the edges than when we look through the middle. Astronomers call this phenomenon limb brightening. Crab-like remnants. These remnants are also called pulsar wind nebulae or plerions, and they look more like a blob than a ring, in contrast to the shell-like remnants. The nebulae are filled with high-energy electrons that are flung out from a pulsar in the middle. These electrons interact with the magnetic field, in a process called synchrotron radiation, and emit X-rays, visible light, and radio waves. The most famous nebula is the Crab Nebula, hence the common name, crab-like remnants. Composite remnants. These remnants are a cross between the shell-type remnants and crab-like remnants. They appear shell-like, crab-like, or both, depending on what part of the electromagnetic spectrum one is observing them in. There are 2 kinds of composite remnants, thermal and plerionic. Thermal composites, these SNRs appear shell-type in the radio wave band. In X-rays, however, they appear crab-like, but unlike the true crab-like remnants, their X-ray spectra have spectral lines, indicative of hot gas. Plurionic composites, these SNRs appear crab-like in both radio and X-ray wave bands, however, they also have shells. Their X-ray spectra in the center do not show spectral lines, but the X-ray spectra near the shell do have spectral lines. Thanks for watching. Please like, comment, share and subscribe.